could we create something using AI that would let us offer something to our customers that we never could before? Something that's truly new and interesting and innovative, and spawns a whole new line of business, and a whole bunch of new, profit. Right?
Hey everyone, and thanks for listening to and watching another episode of The Chief AI Officer. My guest today is Barclay Brown, who's Associate Director of AI Research at Collins Aerospace and Chair of the AI System Working Group at Incozy, and also author of the book Engineering Intelligent Systems. Barclay today is not representing Collins Aerospace, but can speak to a wide range of topics on AI after a long time working in it. Barclay, thanks so much for joining the show.
Thanks, Ben. Glad to be here.
Yeah, I'm excited to dig into a lot of the topics we have for our audience today. Before we get into those, can you share, maybe the personal moment when you first realized the transformative potential of AI and how that had impacted your career?
Well, it's a good question. I guess I'd have to go back to when, if you remember, in IBM a number of years ago in 2011, put out this system that competed in Jeopardy game, and this thing called Watson, right? And I was in IBM at the time. I didn't work on Watson, right? But I started giving talks about it to various audiences that wanted to hear about Watson and stuff. And as I did it, that's what fascinated me, right? Was that a computer could do what was previously thought to be really a human thing, figuring out Jeopardy questions, which are intentionally tricky and stuff, right? If a computer could figure that out, then we're really onto something with AI. So that was kind of the spark. And it kind of, just as you said, kind of shifted my focus to, okay, I want to go toward AI stuff. And I've been doing that dramatically since then.
Yeah, we spoke about that a little bit before we started recording. I didn't know that was the moment for you. That's so funny. Given that Dave Ferrucci, who led that team at IBM, is our founder at Elemental Cognition. It's amazing to see that inspired you. Now that you're working in AI, you've been in the industry. How would you describe the current state of enterprise AI, and maybe particularly in the aerospace sector, if you have any views there?
I think it's easy to say that it's the most exciting time in AI that there's ever been, because if you trace the history of AI, there's been little spurts of enthusiasm that started in the 60s, for God's sake, right? I mean, as soon as computers came along, people imagined thinking computers, and they imagined that to be not that difficult a problem. Like, let's get a few people together for a few months and we'll figure out this AI thing. This turned out not to be the case, right? And resulted in kind of ups and downs in AI over the decades since then. But with the advent of large language models and some of the breakthroughs that we've seen just in the last few years, small number of years, there's a huge resurgence in AI. So everybody's interested in AI, and everybody's looking now. I think they've gotten past the hype and saying, all right, what's it really good for? How can we really use it to drive benefit in our companies and our businesses and our personal lives even?
Yeah, and what are some of those kind of use cases and benefits? I know we all hear the low stakes use cases of just like translation, content, summarization, or even, I'm a marketer, just like the marketing use cases that exist there. But obviously in aerospace, I'm sure there's a completely different set of use cases available to you, and just in the industry. How do you think about those use cases and the application of the technology?
Well, it's a good question. There's a wide variety. And let me back up to what do we mean by AI? And I've got what might be a little bit of a unpopular, kind of a minority report opinion on what the meaning of the term AI is, right? So I think the way we use the term artificial intelligence now is we use it to mean a collection of technologies that we've chosen to call artificial intelligence. It's a little bit circular, right? Because there are things, McCarthy, who coined the term artificial intelligence, quipped at one point, he said, once something works, we don't call it artificial intelligence anymore. We were talking about IBM, right? Deep Blue in 1996, 1997 that beat, Garry Kasparov at chess. Most people would look at how Deep Blue worked today and would not think that that's AI technology. They wouldn't call that technology AI because things have kind of moved on. Yet at the time, that was very artificially intelligent because it could play chess at such a high level, right? So the definition of what intelligence is so fluid. So anyway, my point is, coming back to your question, how you figure out use cases for AI, you have to look at each technology. So the use cases for large language models could be quite different than the use cases for more conventional deep neural networks and prediction and classification kind of applications, or understanding large volumes of data. That I'm in aviation, right? So there's tons of data that comes off an aircraft. They accumulate huge amounts of data from all the sensors and the engines and everything. On every flight, all airlines do this. What do they do with that data? What kind of intelligence can they get out of that? And that's still an open question. Can they do some things like figuring out when a certain component should be replaced, so before it fails, right? Things like that. That's a natural one. But are there many other things that could contribute to safety or to profitability or even to passenger comfort and things like this? So it depends on the technology. And we could talk about any particular technology. But just another overall comment on applications. This is the game. This is the hard game right now that corporations are playing and all companies are playing is, what can we use this for that's useful? It's fun. Our people want to play with it. They want access to it. They want to try things and stuff. But what can we do that's really going to help us? And help us, fortunately, boils down to a couple of easy things to identify. One is, can it save time? So if I have a boring little task over here that maybe doesn't even take AI very much or a little bit of AI or something, but it saves 3 hours of 4,000 of our engineers' time every month, then that's going to add up to some real benefit, even though it's kind of boring, right? Whereas something that may be real, sexy and cool and the latest technology might not really save that much, might not really help that much. And then there's another category of not just time saving and cost saving, but new opportunities. And to me, this is the really interesting part. Like, could we create something using AI that would let us offer something to our customers that we never could before? Something that's truly new and interesting and innovative and spawns a whole new line of business, and a whole bunch of new, profit, right?
Yeah. So it's like there are those greenfield opportunities, the ones that really impact the bottom line. And, everything in between, there's so much opportunity for the enterprise. It's funny you mentioned at the beginning of that, the definition of AI and all of these different systems and the fact that you only think about it as technology until it's so common that it kind of disappears in your life, right? I'm sure we're seeing the same thing. All of those different systems, right? I think we think so much about generative AI has become synonymous with large language models, but there are all of these other systems. And that's particularly what we do at, elemental cognition, as well as neurosymbolic AI, kind of combining the best of large language models with the best of formal reasoners and formal computational systems. And a lot of what's happening in the industry feels like throwing the baby out with the bathwater, forgetting about all those other intelligent systems. And I mean, you've written so much on this topic and about engineering intelligent systems. Is that what you're seeing play out a little bit? Or are you really picking and choosing the right technology for the right use case?
It's hard, and it's hard to pick the right technology. I'm a real pragmatist, right? So if the technology we have now works this way and another technology comes along that works better, let's use that. I don't want to get hung up on a technology. So there's some people who I think are a little too hasty on that. So large language models, in my view, we're in the early stages. We're not at the end stage, right? We're just beginning. And so the problems that are coming up, things like too much hallucination or, mid-memory forgetting, catastrophic forgetting, all these different issues in large language models could be solved. I mean, they may be solved in the next couple of years. So that's one way to think about it. Maybe they'll be solved soon. The other way is those are fundamental fatal flaws, and we have to push large language models aside and do something else with knowledge graphs or with something else, right? And to that, I just say, well, maybe, let's see, right? The large language models have a certain performance level now. And if someone comes along with some other technology that's better, okay, great. But we don't want to jump to a new technology because of some perceived problem in the current technology, because that problem may get solved.
I mean, you're on the forefront of this in the industry, right? How do you, and you're managing AI research across, I'm sure, a number of business units, a number of use cases. How do you actually manage that process?
Well, that's not straightforward. And again, I'm not speaking specifically from Collins, but just from the industry, right? That is the trick, right? Because the people in the business unit almost for sure don't know enough about AI to say, okay, this is a problem that could really be addressed with a certain AI technology. Conversely, sometimes the AI groups, those experts, don't know enough about the business. And sometimes the AI people, quite frankly, they're a little bit enamored with the technology. So they're a little bit, like someone with a hammer looking for nails. I mean, because I got a hammer, I'm looking for some nails. And if something looks halfway like a nail, I'm going after it with this hammer, and that may or may not produce the best, best kind of solution. So what you're pointing to is exactly the hard problem. How do we see what the opportunities are in a business? And I like to start sometimes, just as one kind of strange approach maybe, is starting from the very top. So start from the most strategic objectives that some business, a company or a division or whatever has, their most strategic objectives, and think from that and say, okay, now how could AI empower that? And sometimes you have to start and go down a number of levels, right? From that top level, high level objective. And not high level, like make more profit. That's too vague and too general, right? But something more specific. And how do we get down to what AI can empower? And it's an interactive process. There's a lot of discussion, and there's a lot of figuring out right sizing the technology. Because sometimes people will describe, if we only had an AI that could do this, this, and this. And I'm saying, I could do that, and that with 100 lines of Python. So, even though I'm an AI guy, let's have somebody write the 100 lines of Python, do that, and then go on to something else, right? We don't have to jam AI into it. Another example of that is sometimes people want to jump to the latest AI technology immediately. So, for example, they want to fine-tune models. The first thing out of the gate is, you have custom data, let's fine-tune a model. Well, that's not the place to start. Start with things like, RAG and RAG is retrieval augmented generation, right? With large language models. And start with that, see how far you can go. And even before that, do your prompt engineering. A lot of the problems people have with large language models is because they don't understand how to prompt them well, right? And there's a lot of refinement in how you prompt them to get the right answers. And you can eliminate a lot of hallucination by prompting them correctly, So you work your way up to the technologies rather than starting with, I just read this thing on fine tuning, so let's do that.
Yeah, it's funny you mentioned that, something you can solve with 100 lines of Python, and then like this problem with prompt engineering. Can you talk a little bit about that? Because it's also an interesting problem, right? Where you have these immensely powerful tools in LLMs, and you have prompt engineering, which you could argue whether it's engineering or not. It's certainly not engineering in the true definition of the term, I guess. Or like how do you think about that? Because there's a lot of error that comes in there. There's a lot of unpredictability.
Yeah, well, prompt engineering, it was thought to be, the next big profession, right? It was going to be a whole separate profession. You heard all this stuff, right? And I don't think that happened. And I think the reason that that's not going to happen is that prompt engineering is one important skill that you need to develop large language model-based applications. But it's not the only thing you need, right? You need prompt engineering. You also need programming, because you've got to write the application framework. That's going to be in code. It's not just going to be a chatbot, right? It's going to be that capability built into an application. So the prompt engineer, I tell my workshops that I do on this, I look at them and I say, here's the big takeaway for today. You ready? Your prompts are too short. And that's almost always the problem. You're not giving the model enough specificity, enough direction, enough a persona, all these techniques, right? Step-by-step examples, chain of thought prompting, multi-shot prompting, all this stuff we know about, right? You're not using that. You're just saying, write me a business plan for next year. And you're going to get garbage, with something that vague and that open-ended, right? Or you try to make the large language model do a whole job in one step, like writing a business plan, right? Even if I gave it more detail. Probably what makes sense is start by giving me an outline of a business plan for this kind of business, for this kind of audience, with these kinds of customers and this kind of market and this kind of situation. And then maybe it gives you an outline, all right? And then maybe I can, for each step, say, here's the step. Now write me an outline for this section. Okay, and there's more detail. See, and I can use it as a partner to develop something, but I can't just wide open say, here, go do this.
Yeah. You also wrote a book, Engineering Intelligent Systems, where, I have only briefly looked at some of like what it has talked about, but it sounds like you take almost like a modular or component-based approach to AI and how you can engineer those systems. Can you talk a little bit about that? Because I've heard you make suggestions of that in the way that you're thinking about the applications of the technology.
Well, it's very much a systems engineering kind of approach, right? Because systems engineers think about systems as modular components that interact and that work with each other. So someone might say, well, all right, I've got this AI component, but I'm worried it's going to misbehave. Worried it's going to do something crazy. And of course, you try to minimize that, but okay, I'm still worried. I'm still worried it's going to do something crazy. Well, but I still want to use it. So why don't we have another component over here that watches over it and makes sure if it does something crazy, maybe this other component, much more basic, maybe it's not even an AI, it's just kind of logic, takes over. Says, no, you're getting crazy. I'm taking over here. It's funny. It reminds me of a story of two pilots that are flying, right? And one thought the other one was doing something that was a little bit crazy. And the one pilot said, he used his arm. He showed me this. This is really funny. He went like this, boom, which kind of knocks the other pilot's hands off the controls. And he says, my airplane. So he thought the other pilot was doing something crazy. So he took over for the safety of the airplane. It wasn't personal, right? So you have components in a system kind of operating that way, kind of watching over each other. And that's actually coming to now be the pattern that's emerging for large language model application is these agent workflows, right? They call them agent or agentic workflows, which are basically multiple LLMs or one LLM acting different ways, cooperating together. So one's writing and the other one is checking the writing and providing feedback. And then the other one's rewriting and the other one's checking, and they're kind of working together. And they could even be the same large language model, just instructed to act differently, in those different kind of agent personalities. So my metaphor that you might have seen in the book is, how do you prevent human beings from murdering each other in a society, right? You want to have a society that doesn't have murder going on. That's the objective. Okay. So how do you prevent murder? Well, the answer is you don't. We don't have societies that prevent murder. It's possible. How could you prevent murder? Lock everybody up. This is the iRobot solution, right? If you lock everybody up for their own safety, then nobody will get murdered. But we don't do that. So we don't actually prevent murder. But what we do is we provide pretty strong disincentives for murder, like police, courts, prisons, sentences, criminal records. All that stuff should act as a disincentive, right? But it doesn't prevent it. So you have the same kind of thing in systems. So you have components that are the police and the watchers and the things like this that work together to make the whole system safe.
Yeah, and that's very interesting way of thinking about it. And in that system, I guess, you gave the example of an LLM monitoring itself, or like there being multiple agents. Do you think we'll get to a place where LLMs can actually do that with 100% accuracy and reliability in the way that we would expect formal systems to do it? Or would you rely on, you mentioned logic, would you rely on like a more formal logical system to do that part of, in this system?
Well, yeah, you certainly could. I don't think there's any theoretical block to it being 100% reliable, because your watchdogs in your system, these part components could simply require 100% accuracy. And if it's not accurate, shut it down, take it over. You know what I mean? It could exert whatever pressure it needs to on that. And of course, depends on the application, right? Because humans are not 100% reliable at anything. So sometimes AIs, we talk about it being better than a human, sometimes that's not a real high bar. Even something, the classic application, I'm going to show you a photo and you tell me whether there's a cat in it or not. Well, you're probably going to get a lot of them right, but you're going to get some wrong. Because what if you see it and you don't see the tiny little tip of a cat's tail in the corner, right? So or you're not sure, well, I see this little tail. Now, do I count that as a cat or do I not count it as a cat? And you have doubt, right? So human performance has some error level, right? And so how do we expect AIs to do better than that? And often they can, but perfection is a hard ideal to reach.
It is a very, very hard ideal to reach, but hopefully we can, hold AI systems to a slightly higher bar, but it's going to be a tough one and an interesting question. Coming back to organizations and enterprise, how enterprises are starting to deploy this technology or have been for decades. What do you see as the biggest obstacles that they face when they're bringing these systems into their operation?
There's a couple, and I probably see things a little bit differently than some in this. While it can be useful to say, all right, we're going to have this little special group of AI people in our company, right? And we'll assemble them and we'll hire them or whatever, right? And we have and they'll just do AI to everybody. They'll get AI out there. That's going to have limited benefit. The kinds of things that really take hold in a corporation are things that are distributed. So, I tend to put a lot of emphasis on education, educating different people at different levels about different kinds of AI and different aspects. Yes, I'm teaching, I give you an example. I have this course that I taught called Excel with Python for Engineers, right? And the idea is to teach engineers just enough Python, just a little bit from scratch. They don't have to know anything at the beginning, right? But I teach them just enough Python in just a few hours so they can read data out of Excel spreadsheets, do some stuff with it, and then write out other spreadsheets. It's kind of funny. It's a little, if for a Python person, you're like, well, that's so easy, But remember, these people are brand new. They don't know any Python, right? So it gets them into it a little bit. It's like a gateway drug, right? So I call it gateway to AI because doing that is actually the beginning of getting you into the world where you might be building AI applications and so on. So that's right for some people. I want engineers to see Python as a tool that they can use, just like they use Excel or PowerPoint, which they use a heck of a lot for engineering work, right? But to use Python as well, right? So education is a big part of it, but then also education at other levels, right? At, higher levels of people understanding the breadth of applications, understanding ideas. A lot of my talks are meant to be sort of inspirational. I can have all these different inspirational examples of what you can do with large language models. And they're meant to just, not just amaze people, right? But say, that gives me an idea. Maybe I could do this, and they start thinking creatively about stuff. And that's vitally important. That's how it's really going to get into the fabric of an organization. So the other side, besides education, the other thing you've got to give people in your organization, this is not easy, is you got to give them the tools. So, they're home, they're using ChatGPT, they're playing around with ChatGPT, they're writing Christmas poems for their family and all this stuff, right? When they go to work, do they have access to something similar so they can try it with company data? They can't use ChatGPT because you can't put company data in there. But what have you given them something at work that they can try this stuff at work somehow? Do they have, environments where they can do these kinds of applications? Do they have the tools? I have a colleague who said, you ought to take Anaconda. Anaconda is a big Python distribution that has a bunch of libraries and stuff in it, right? We should put it on everyone's machine. Everyone. I'd like, you're crazy, He says, no. We have to send the message that it's a tool for everybody. You don't have to use it, right? But it's there. And it's a tool that you can use. You can use this or that, little stuff. And you get people into it. It's a revolution. It's a huge revolution, by the way. And it has to start with companies treating data as a resource kind of for everybody. The data's not locked away somewhere. If I see something interesting I can do with some company data to do something useful for the company, I ought to be able to do that and not have to prove that I have a super high ROI on this project that I'm just now thinking of. That's a high bar. A lot of things don't get going because of that. So we have to change the culture a bit.
Yeah, I love that in terms of education and the tooling and essentially the empowerment, right, of everyone on the front lines of the problems, because they're solving problems every day in their jobs. Obviously, larger AI implementations, research takes a lot of money. You mentioned ROI. Like, how do you balance the interests of the stakeholders, like you mentioned, those people in the company, the pursuit of innovation, and then I guess the financial impact that you also have to show?
It's a balance, right? There are some things, and I used to do a lot of ROI stuff, right? There's this whole philosophy about how to think about ROI. There's a couple of philosophies. One is probably about 7%. Yeah, that's good. Call it 7% ROI. This other one, it looks more like 3%. Let's call it 3%. That's nonsense. I'll use clean language here. It's nonsense. And because it's not based on anything at all, right? And what I tell people, there's no such thing as a 3% ROI or a 7% ROI. Nobody is measuring things that precisely that you could see a 3% ROI. Now, ROI is not going to be 3%, it's going to be 10 times, or it's going to be nothing. It's going to be very visible, or it's going to be undetectable, right? So, and some things are very visible. I worked on an ROI analysis years ago for another company, and their ROI case was sort of like the following. Since we've been applying this technology, we feel it makes us more attractive to our customers. And so we feel like we're winning more business from our customers because we're more attractive because we're using this technology. And I said, this is interesting. How much more? And they said, well, we normally get a lot of follow-on business anyway. I said, how much follow-on business do you get? Well, we probably win 6 out of 10 new opportunities that come along from our customers. Okay. Now with this new technology that you're using, about how many you think you're going to win? He says, well, we've won 100% so far, but let's just say maybe we win 85% or 90% now going forward because of this new technology. Well, and I said, well, how much are these opportunities worth? And of course, this was big companies. These are big numbers, right? So you do a little bit of multiplication, and that's huge. The difference between 70% win and 90% win is huge in that new opportunities. And so people don't think about ROI that way, but that's really the impact, right? That's the result of the technology.
Yeah, so really set some basic guardrails around what are the assumptions you're operating under, and let's get specific about the numbers. I think it's good advice for anyone in the field. Looking at the aerospace industry and maybe more broadly than that, even, how do you envision Gen AI really transforming the design and manufacturing process as well?
Yeah, that's a harder one. There are certainly some things that engineers can take advantage of. There are of course people trying to make the leap of, well, gee, we'll just get the AI to design stuff for us. We won't need engineers anymore. And I think that's a leap too far. I mean, I love to tell a story about how engineering is depicted in science fiction. You've seen this, right? You've seen Tony Stark and Iron Man, right? And he's sitting there, he's doing engineering in his basement, right? But he's got this AI that is kind of his partner, and it's able to make him more productive. Or you watch the crew of Starship Voyager. You remember this? They were designing the aircraft, and they were using the holodeck, right? And they were saying, okay, now here's the ship. Now let's change the wingspan. It just changes in the holodeck, right? And they can look. And so they're doing the engineering, but the tools are helping them be much more productive. And that's starting to happen. There's still more low-hanging fruit because engineers are workers too, right? And so it might be that we can more easily save engineering time by automating simple stuff and just leave them more time to do engineering rather than trying to make the engineering better. There's studies that show that somewhere between 25 and 30 and even 50%, some say, of people's time is spent searching for information to do their job. So maybe we could go to work on that, right? And I can give the engineers back a bunch of time to do engineering because I can provide the information, or some AI, right, somehow can provide the information they need. And large language models seem like a good fit for that too, right? Because they can do things more than just a search, right? They can produce information based on results of search, things like that.
Yeah, I agree. I think that's the view that a lot of optimists in AI, the people that are in the field, see this as really freeing up humans to be more creative, more productive, like applying the things that for now we have not been able to automate as effectively. And so it's very interesting to see how the industry is going to evolve even over the next 5 years with how quickly these things are changing. As you think about other companies that are trying to deploy AI in their organizations, what's some advice that you would offer to someone just getting into this or stepping into your role, for example?
I mean, it's the three things we talked about, right? Training, you got to provide training. And you kind of got two ways to go with training, right? You can do internal training in the company that you can create yourself, or you can have external training. And there's so much amazingly good external training on the internet now that you don't have to reproduce that in-house. So sometimes the best is a mix where you do some in-house courses that focus on your business and on what you're doing and your applications and stuff. But then you guide people to a bunch of the external training. And the external can be universities, or it can be Coursera. It can be one of my favorites, deeplearning.ai, which is an Andrew Ng project, right? That has courses that he presents through Coursera and short courses, real amazing stuff and really well done, right? So that's great stuff. So training is part of it. And then the other part of it is the data, getting people access to data, making it easier for them to use data in the company when they have ideas for things they can do, making that somehow easier. Right now, a lot of companies, especially those in my industry, in defense and stuff like this, you have a lot of protections. It's almost like you have to prove the need to know before I can access anything. And this can be a real impediment to innovation and so forth. And even in the military, I hear about this, right? That the military officers talk about sharing information between services or even within the service, within directorates and things like this, right? It was exemplified, a story I heard. Somebody said, they called up the general and said, hey, we wanted to share more information so we can collaborate and stuff. And the general said, I'm all for it. Send me what you got. So he's willing to receive, but that's different than being willing to share everything, right? So we have to change that culture somehow, still in the bounds of wisdom, but allowing the innovation more. And then the third area is the tools, right? Giving people the tools to be creative somehow.
Yeah, 3 great pieces of advice. You mentioned the data in particular. That's one thing that everyone, as you said, all enterprises, aerospace, defense in particular, with these large language models, obviously you can deploy things on-prem, you can fine-tune your own models, but how are you seeing play out? Are you seeing a reluctance to dump data into these systems, and how are they dealing with that?
Yeah, and it's a process. I mean, it's, and we and everybody else are struggling with it. Like, what data can I put in what model where? And I tell people, look, it's simple. It's not about the model. It's about where the model is running. So it's not about, can I put this data in this model? It's, can I put this data in this model running on this machine where it is, right? Is it on a private cloud? Is it on an in-house server in a closet somewhere? Or, and I think this is the future, by the way, you ready? Here, I'm going to make a prediction, right? That in a very small number of months, probably even not even years, we're going to have good, usable generative AI capabilities on our PCs. I can already do it. I'm already doing development with an LLM running on my own PC, a good LLM, Mixtral. I mean, that's a nice open source LLM, right? I'm using it. And it's running on my own PC. And I don't have that big a PC, right? But you can get them to run. Quantization helps, reducing the size and all. But I can get it to run enough. And see, what's freeing about that is I don't have to ask anybody's permission to use it for data whatever data I can have on my machine, I can put in that model, because that model's right on my machine. It's not going anywhere, right? It's right there under my control. So the more we have those capabilities in workstations, that's going to be a breakthrough. And we, as you know, there's already companies working on chips that are going to go in our PCs and even in our phones, right? That can start doing this AI stuff right there locally. And that's going to be a huge capability for developers. I mean, I know we think of the end user, so I'll have a chat bot on my phone. No, that's not the big deal. The big deal is I can build applications using that technology that runs right on my PC with my data and stuff I control. It's funny. It's the old pattern again of, do I have to deal with the computer people in the glass-walled room with the special air conditioning somewhere down the hall, or can I do it on my PC? And for years, it's been, I can do it on my PC. Look, well, now with LLMs, we're almost back to the server room, but then maybe I can get that onto my PC, right?
Yeah, I think that's a great prediction for people to watch out for, and getting those types of technologies on the edge, right? On edge devices and everything is something a lot of people are watching. And I imagine, I guess in part, our bet would also be that when people start to combine those with formal systems, right, with other logic systems to run really hyper efficient applications, there's going to be so much innovation in this space, whether that's on the edge or like in the cloud or anywhere else. But that's a very interesting prediction. Do you want to make any other predictions looking 5 years out to the end of history? What do you expect?
Yeah, I mean, what goes along hand in hand with that first prediction, right, of we're going to have, decades ago, gosh, this is when I was in college. That was decades ago. I had a boss, and he said, I'm seeing predictions that what I'm working on now, my big computer in my closet over here, I'm going to have in my phone. And then in my closet, I'm going to have something that used to be down in the data center. And he says, now in 5 years, what's in the data center will now be on my phone. So what's going to be in the data center? So there's this process, and this has been happening over the years. So when I say you'll have certain generative AI capabilities on your PC, great, but there will still be something even more advanced working up in the cloud, right? In the big system somewhere, tying things together and so forth. So can you imagine, we're not just a network of dumb Windows and Mac systems around, we're now a network of AIs, right? Where everybody's entry to the network is an AI, and that AI is talking to the other AIs. And you start thinking about things like, will negotiation for business deals be done AI to AI? They'll have my AI call your AI, we'll make a deal, Why not, right? If we can set up the rules and the parameters and so forth, right? So it will change how we think about things. Everything that we touch will be smarter and interact in smarter ways with other things.
Yeah, I think that's a very interesting future. I wouldn't trust ChatGPT right now to negotiate a multi-billion-dollar deal, but certainly there's a lot of scope for innovation. Barclay, that's all we have time for today, but thank you so much. I learned a lot talking to you today. If our audience wants to reach out to you or learn more about the work you do, where should they go?
I'll tell you what, I'll give you a website that I'll make sure it exists by the time this comes out, barclaybrownbooks.com. So barclaybrownbooks.com, you'll see a feature of my latest book, and I'll try to put some other stuff up there that might be interesting to people.
Amazing. Well, I hope that was the launch of the website. First time on this podcast, but you heard him go to Barclay Brown.
It was up and it's messed up now, but I'm going to fix it. So yes, it's right.
Got it. Okay. Well, Barclay, thanks so much for your time today. It's been a pleasure.
My pleasure. Thanks for having me.